Compute the shear force and bending moment diagrams for the beam shown and find the maximum deflection. Assume rectangular cross-sectional area of 0.4 meter into 0.6 meter, Young's modulus of 210 gigapascal, Poisson's ratio 0.27. Here the inclined load is acting on the beam at different locations. So now we are going to solve the given problem statement using ANSYS software. So in the ANSYS, go to element type, add beam, element, material properties, material models, structural, linear, elastic, isotropic. Check the problem statement for material property. There is 210 gigapascal, 210 E9, and Poisson's ratio 0.27. Go to section, beam, common sections. Check the cross-sectional area 0.4 into 0.6 meter, 0.4 and 0.6 meter. So now modeling, create key points. Inactive coordinate system. Key point number 1 is 0. Apply key point number 2. That is 1 meter. Key point number 3, 2 meter. Key point number 4, 3 meter. Key point number 5, 4 meter. So create a line, straight line. So now I am going to meshing this geometry. Go to meshing, mesh tool, lines, set, pick all the lines. So pick all the lines. So each line number of element divisions will be 10. So that we are getting 40 number of elements. Go to mesh tool, mesh, pick all. Now we are going to apply loads and boundary condition. Loads, define loads, apply structural displacement on lines, on nodes. The left end is, that is simply supported ux, uy, uz, rotx and roty. The right end is roller supported so that the displacement along x direction is possible, so that uncheck the ux, and remaining, that is uy, uz, rotx and roty is possible. Arrest the displacement, that is 0. Click OK. Now I am going to apply the loads, so that we need to rotate the nodes. Go to modeling, rotate, create nodes. So in nodes, the rotate nodal coordinate system. I am going to rotate the nodal coordinate system. So here first we have to identify the coordinate system nodes at 1 meter, 2 meter and 3 meter. So go to list nodes. For 1 meter, node number 2. For 2 meter, for 1 meter, node number 2. For 2 meter, node number 12. For 3 meter, node number 22. For 1 meter length, at 1 meter length, the node is 2. At 2 meter length, the node is 12. For 3 meter length is, the node is 22. So remember these nodes. First we have to rotate the node to active coordinates by angles. How much angle? So it is rotate in clockwise direction. So node number 2, apply. Here the angle will be 60 degree. So here it is a node, so 90 plus 60 degree. We are going to rotate this node around 150 degree. Rotate about z axis. So 90 plus 50. Apply. 90 plus 60. Apply. And node number 12. Apply. There is 90 plus 45. And node number 22, apply 90 plus 30. Okay. So now we are going to apply the forces. For each, check the problem statement. For node number 2, we are going to apply the 100 Newton force. For node at the location of 2 meter, we are going to apply 200 Newton force. At the location of 3 meter, 300 Newton force. 100, 200 and 300. So go to loads, define loads, apply structural force or moment on nodes. Check the node number to enter the value in the command window. Then apply Fy direction. There is 100 Newton force. Apply. And similarly, for node number 12, apply 200 Newton force. For node number 22, apply 300 Newton force. Okay, that's all. Now we are going to solve the problem. Solution, solve current load step. Then click OK. So now go to general force process. First we have to draw the shear force and bending moment diagram. Go to element table, define table, add by sequence number SMIS 3, and similarly by sequence number SMIS 6, by sequence number SMIS 16, by sequence number SMIS 19. Okay, so modeling. So go to plot results, line element results at node I SMIS 6, node J SMIS 19. It is a shear force diagrams. Go to plot controls, style, change the background colors, reverse video, plot control, save, capture image, and file save as. Then go to line element for bending moment diagram. Go to line element results. But node I SMIS 3, node J SMIS 16. Then click OK. So go to plot controls, capture image, file save. And for displacement plot, go to nodal solution, displacement vector sum. For changing three-dimensional image, go to plot control, style, edge option, plot control, style, size and shape, and display of element. Change the display of element, and again capture the image, plot controls, style, plot controls, capture image, file save as. Okay, thank you.